What is up, guys? This week's long form video, we're going to be talking about composites and just giving a quick overview between the two main types that I like to use, and then from there in future videos we'll dive into more details. As always, I give you guys this information and speak in general terms so you can use it in your day-to-day, whether you're working with another distributor, manufacturer, supplier, whoever you're working with. I hope this knowledge is helpful for you and what you guys are doing can help you out. So again, we're going to be jumping into a composites overview with the focus being both the epoxy systems as well as the urethane systems, and just some basic things there where we'll be able to dive in deeper in other videos in much more detail. So what we're going to go over in this video, or what we're going to cover, is one, let's define what a composite is. The second thing, we're going to go over where we use those and why we're going to use them. And then third, we're going to actually cover what makes up that composite system and why we may or may not choose some different things, whether it's the fabrics or the resins that go into that. Now let's define terms, and in this case, there's just one we need to define, and that is composite. Now, a composite is where we're combining two or more things that may have drastically or potentially drastically different properties, but once combined, all of the benefits of each one of those materials within that system benefit one another or complement one another and can give you a much better system than what either of them or the multiples could be by themselves. Now, as we get further into this video, we're going to go over where and why we use them, but before that, what we're going to do here is just cover what an example composite is. That way you guys have a good idea of what I'm actually talking about when I'm going through our examples of where we would use these, instead of just going, that's cool, Nick, I don't know what you're talking about. This is what we're going to do. All right, and so in this example composite, we have two different sides. We have our resin side and our fabric side. Our resin side in this case, or in this example, is an epoxy, and then our fabric side is going to be a fiberglass. Now on our resin side, or in this example, our epoxy, some key points to note here would be, one, the epoxy is very good for corrosion resistance and it has excellent adhesion, but the epoxy by itself doesn't have very good tensile strength, at least not as it relates to or what could be achieved with a fiberglass or a carbon fiber. Now on the flip side, we have our fabric, which in this case is a fiberglass, and just like the epoxy, it has great corrosion resistance, but then the other two values it flips. So it has poor adhesion by itself, right? It's just a fabric. It doesn't really adhere to anything without something to help it adhere, but it has excellent tensile strength, which is great for mechanical properties, reinforcing strength, things like that. Now, as a composite, so we have our epoxy, right? Great corrosion resistance, same with the fiberglass. But with the epoxy, we have excellent adhesion and poor tensile strength. And with the fiberglass, we have excellent tensile strength but poor adhesion. But when we combine these two things, what we get is we get a bump in corrosion resistance, as a lot of glass flake filled lining systems are the epitome or the top for corrosion resistance. And then what we do is we get to blend the excellent adhesion of the epoxy with the excellent tensile strength of the fiberglass. And so this is going to give us all around corrosion resistance, excellent adherence to the substrate that we're trying to fix, as well as great mechanical reinforcement properties. So where do we use these things? Where I like to use them predominantly is, one, in piping systems. Two, we're going to use them in tanks. And the third place is anything structural. These could be concrete pilings, these could be steel pilings, steel structures, anything like that, where we need to bring back mechanical strength as well as potentially provide corrosion resistance or chemical attack resistance. Anywhere in there, again, the corrosion resistance, chemical attack is generally more on your piping side and potentially your tank side, with the structural system sometimes just being a lower grade or a lower corrosion rate, but just over time, 20-30 years, we now have issues. Now, following up the last slide with where do we use these would be why do we use these. And the first one is to build back wall loss, specifically with tanks or with piping systems. Oftentimes when these things corrode, let's say originally that wall was an inch and now we're down to 200 thousandths of an inch, which would be about 80% wall loss. Now we can work somewhere in there or even less than that, but what we're trying to do is build back wall loss, with the goal being to mechanically reinforce that system so that we can extend the service life and keep it operating. In a lot of cases, what we'll do is we may evaluate a piping system where the client says, hey, I have this issue with the pipe. we had an inch of wall. Now we have about 100 thousandths of an inch, so we have 90% wall loss. It's happening at this rate, so we suspect within 2 years we're going to have an issue, and we want to reinforce that so we can keep operating and hopefully extend the life until we can replace it in, say, 5 years, 10 years. It could be a month, like, hey, I just need to get to this downtime. But what we're trying to do is extend the usable service life of that system. So in our case, we already hit on what an example composite was, being the epoxy fiberglass example earlier on, but what actually makes up a composite, at least as far as what we're concerned and what we're trying to do. So in simpler terms, a composite composition is going to be one side is going to be your resin, and that could be a 1-part, a 2-part, a 3-part, doesn't matter, but you're going to have your resin side, and then you're going to have your fabric side. The two main resins that I like to use are an epoxy or a moisture cured urethane. And the moisture cured urethane, as you would expect, cures in moisture, so generally these are in a sealed bag. And then what that resin will allow you to do is work much more quickly. It's not going to be as strong as an epoxy in the sense or in terms of what we're trying to do, but it allows you to work quickly, whereas the epoxy side is for more aggressive environments where we either need more strength, more chemical resistance, or both. That's where I like to switch over and use the epoxy. Now the fabric is where we get all of our strength from. And yes, we do need the resin to actually cure that, to give us our strength, right? The resin is going to be what adheres this to the piping system, to the tank, to the structural concrete, whatever that may be. But in terms of full-on mechanical strength or mechanical loading, this is where the fabric's going to come into play. And now the two main types that I like to use are going to be fiberglass or carbon fiber, and both have their benefits. We'll dive into that in a later video because there's a lot that goes around with carbon fiber is the best, and really that's just not always the case. From a pure strength perspective, I guess you can make the argument, but there are cases where you don't necessarily need or would even want all of the strength that carbon fiber can provide. Now on the flip side, or not necessarily the flip side, but on the other side of this is, how is that fabric actually put together? So we have different types. We have our woven type, which could be a standard over-under woven. You can go 2 over, 2 under. You can go with different like mock lino weaves or stitched biaxial fabric. So there's a lot of different types in that construction, and they all do different things. Some are better for field layup, some are better for in-shop layup. Some provide more all-out strength but are more difficult to work with, and some are fantastic to work with but don't provide as much strength or allow you to contour the same. And then the other side would be a knitted. To my knowledge, there's only a few main types, but for what we do, or for what I do, I don't really use the knitted just because for 99% of what I'm doing, the woven is much stronger and can just yield a better result. And for the 1%, often it's already fixed either before I get there or we can make the woven work. And so generally I steer clear of the knitted. Not that it's a bad fabric, it's just an extra thing to carry, and so I don't do it, but the people that have it, they're phenomenal. And anytime somebody says, hey, I'm using this knitted here, say, hey, keep using it. If it's working, keep doing it. It's a phenomenal system. And then here's my weekly gripe. Again, there is no best here. We have two different resins, the epoxy, the urethane. We have two core types of fabrics that we can use, whether it be your carbon fiber or your fiberglass. And so really that's giving you 4 different combinations, not including the construction of the fabric itself. So there's a lot of different types that we can use, and so I try to steer clear of this is the best. Sometimes you may want a really thick fabric so you can build up. We're doing a really high pressure application, and in that case it's the best. Other times we're doing repairs on a 1-inch piece of pipe and we need to be able to contour, and that heavy fabric, while it's really good for strength, isn't going to be good for that application. So again, there is no best. It all depends on what we're trying to do. So I hope this helps you guys. As always, really appreciate you guys tuning in here. Please drop a comment down below on what else you would like to see me comment on. If you have any questions, give me a shout. Take care. Godspeed.